Now, I'm sure that some of you had had some interactions with LBBstore. Now, I haven't seen his name in a while, but I just happened to notice it on this comment thread, and he was already in full debate with a couple of Globers, but I thought I'd ask him a couple of questions. So we went back and forth about 6 or 7 times about surveying and perspective, and he finally sent me this Imager link. So it was titled, How Do We See the World? And he had some graphics and a few photographs with his explanations, but of course I didn't agree with everything. So I made some copies of his graphics, added my views, and then sent him a link to my Imager posting. So let's see if LBBstore has anything to teach us about perspective. We'll start with the top drawing and the text that is yellow. So to assert we see in absolute sizes, the observer would require a 180-degree angle view from their eye to the top and bottom of the object, which is not possible. Name one object we view in absolute size. You know, why are flat earthers saying this all the time? Nobody is asserting that we see in absolute sizes. I mean, I'm sorry, this is a false claim. But what we do is when we talk about an object, we do talk about its absolute size. But that is a big difference. We use actual size because not only does it not change with distance, but now we have an understanding of how big or small that object is compared to other things. I mean, we all understand that things appear to get smaller in the distance. We see this every day. But if somebody asked you, well, how big is that building in the distance? Is anybody going to reply? Well, from here it looks to be about 1/4 degree in angular size. That doesn't really tell you anything. Now, yes, there are times when we do use angular size measurements, but generally we do talk about objects in their actual size, and there's no way that this means we are asserting that we see in actual size. So let's take a look at the drawing on the bottom left. Notice in the angular size image, as the boat trends into the distance, the angle below eye level would hit the vanishing point of vision before the angle above eye level, causing the boat to appear to vanish bottom up. So does LBBstore really think this would cause the boat to disappear from the bottom up? I don't think he really thought this one through. Well, this was my reply. So on the top drawing, we have a smaller angle on the top of the boat. So as that boat got farther away, then why wouldn't the boat vanish from the top down? Because this angle is smaller. And on the bottom drawing, we have a smaller angle in the middle of the boat. So why don't we see a gap in the boat? Because this angle is smaller and vanished first. Now, this concept has been around for a while, but I want you to listen to what I call the birth of perspective logic. Now, this was about a year ago, and it is Nathan Oakley, but don't worry, he's not ranting or raving. In fact, he seems a little proud of himself. So let me set up the scenario. So what he's doing is he's talking about a brick that is not visible because it's below the resolution limit of the human eye. So I'll use 0.02 degrees for that since this is commonly used. So here we have the brick. Then he adds another brick above the first brick, but since they aren't together, neither brick can be seen. Next he combines the brick, and now together they are above the resolution limit of the human eye. So what do you think would happen? Well, if you understand how perspective works, you would say, yes, we can just see the combined bricks, but we can't make out the individual bricks. So let's see what Nathan has to say.
So what you're saying is it doesn't change the bottom angle, that's still too small to see, but because we put another brick on top, the brick that's on top has increased the overall angular size, so you might see the brick that's on top, but you still can't see the brick that's at the bottom.
Oh, you beautiful bastard, you.
Well, I
Where'd
disagree.
you get, hold on a second, Apollo. Where'd you get, did you just come up with that?
Yeah.
Can you believe that? And I think that was Quantum Eraser who enjoyed the taste of the BS that Nathan just pulled out of his rear end. So why is the top brick so special? Why couldn't it be the bottom brick that is visible and the top brick that's not visible? Or maybe this is what we would see when we were standing on our head. And what if the bricks are side by side? Would it be the right brick or the left brick that you don't see? But let's continue with Nathan.
But as you've just ably agreed and conceded, the bottom of stuff can just have too small an angle to see it. But the stuff above it can still be seen because it's got a bigger angle. So the bottom brick, being the bottom section of a building perhaps, is gone due to its angular size and absolutely nothing to do with earth curve obstruction.
Well, I'm sorry, Nathan. That makes no logical sense at all, because if that was the case, the building should also be disappearing from the top down, actually from the sides inward too. And let me show another reason why this argument makes no sense. So here we have a photograph with a P900 that was set to 55 millimeters. So if you were there in person, this is approximately what you would see. So therefore, what we can see and not see in this photograph depends on the angular resolution of your eye. Now, if you look up here in the upper right-hand corner, you can just make out a man-made structure. And it just so happens that it is a brick building, but I don't see any bricks. So what happens when we zoom in with the P900? So this is at full optical zoom, and it is quite easy to see that this structure is built out of bricks. And this is full digital zoom. Now I can even count the bricks. So the idea that objects disappear from the bottom up because the smaller details of that object are below your resolution limit are absolute nonsense. And if flat earthers are going to talk about the diffraction limit of the eye, then why don't they talk about an eye test? Because this is how we measure it. There is no one set standard for the diffraction limit of the eye. It varies from person to person. Now we usually see 0.02 degrees as the diffraction limit of the eye. But if you have 20/20 or 6/6 vision, if you're using the metric system, you can see down to 1 arc minute or 0.017 degrees. Now I'm going to use this letter E to show how the letters in that row are designed. So they are 5 arc minutes high, 5 arc minutes wide, and then horizontally and vertically they are divided into 1 arc minute segments. Now I'm sure flat earthers have had eye tests, so they know that you read down the lines, and as they get smaller and smaller, you finally get to a row where you cannot distinguish what the letters are. But you can see the whole letter, it's just you cannot make out the individual parts. What we definitely don't see is the letters disappearing from the bottom up because of the diffraction limit of the eye. So when we analyze photographs, we got to be careful about how we define the diffraction limit. Now with the unaided eye, you can see some man-made structures in the distance, but they are near the vanishing point. And as you zoom in, what was previously below your diffraction limit is now easily visible. And of course, with a P900 at full zoom, you can see a lot of detail that you cannot see with the unaided eye. So let's go back to LBBstore's graphic of the boat, but this time we're going to divide the boat into 3 equal sections. And I'm sure everybody should agree that as this boat goes off into the distance, these 3 angles are going to get smaller and disappear at the same time. And let's do the same with this container ship. So I'm going to start off with one segment here that is 4 containers high. Now I'm going to add 2 segments, one on top and one on the bottom, and all 3 have the same angular size. Now, I'm sure many of you recognize this screenshot of a video by MCtheEmcee. And of course, the flat earthers are going to start making excuses. The hole is hidden by an inferior mirage, or the hole is hidden by waves. Of course, in this video, it is quite obvious that there is no inferior mirage. And how would these tiny waves hide anything? And of course, there's always, well, the hole is below the refraction limit of the eye due to the angle of attack. So let's put this to the test. Here I have counted off 4 containers. Next, I scaled the ship on the left, so the 4 containers over here are the same angular size as the 4 containers over here. And then I added the other 2 segments. So now we have 3 segments that are the same angular thickness. So under what logic is the bottom segment and the bottom segment alone below the eye's resolution limit when we can clearly see the other 2 segments? Of course, when it comes to flat earth logic, it's anything but curvature. So this is only possible with flat earth perspective.